Answer, tell me the answer, children. First question. First question. Let's see. What kind of charge moves? Positive charge or negative charge? What kind of charges moves? Positive charges or negative charges? Children, what kind of charge moves? Is it positive charges will move or negative charges will move? Normally, what kind of charges move? Is it positive charges or negative charges?
Positive.
Normally, negative charges will move, children. Normally, negative charge. Okay, electrons will move from excess region to because protons are there inside the nucleus, no, they won't move, children. Protons won't move. Negative charge only they will move, children. So negative charge, electrons will move from higher potential to lower potential. Okay, first answer. Second answer, anyone, children? If electric current is electric current a scalar or vector? And what is the unit of
Scalar.
current?
Scale.
Amperes. Unit of current is amperes, children. And children, what is current? Current is equal to amount of charge flowing in a given time. Okay, rate of flow of charge. So, in which direction current is flowing? Positive to negative or negative to positive directions are important, no, children. So, it is a vector quantity. It's a vector quantity. Okay. Next, third question, children. What is potential? What is potential? Anyone? Work done.
Work done in moving charge.
Work done in moving a charge is called electric potential. Work done in moving a charge is called electric potential. Okay, children, work done in moving a charge. Work done in moving a charge. Work done in moving a charge is called electric potential. Next question. Fourth question. Calculate the work done in moving 20 volts to 30 volts. Children, here I do. See, from 20 volts to 30 volts, how much work? Calculate the work done in a charge of 5 coulombs. You have to move 5 coulombs from 20 volts to 30 volts. How much
30
work?
minus 20 by 5.
Normally, formula is
VA minus VB by Q.
VA by, if you think this A, this B, because high potential, low potential, W by Q, children. So, VA is how much, children? 30. VB is how much, children? 20 is equal to work by 5. So 10 is equal to W by 5. So answer is 50 joules. Okay, children, like this. So we can write this as VA minus VB also, children. Potential, we can write as VA minus VB is equal to
Potential
W.
difference.
Potential difference, yes, potential difference. Okay, fifth question, children. Electrons are responsible for conduction in conductor. All of you know that. The speed of electrons is not very high, you know that. Then how the bulb is immediately, even though switch and bulbs are far away from each other in a household circuit. How you get initially due to drift velocity, means they will transfer the energy. Due to drift velocity, means they will transfer the energy. So immediately you will get the current. Drift velocity, they transfer the energy. Okay, children? Sixth question. A wire of resistance 12 ohm is 1 in square. What is the resistance? Children, a wire of 20 ohm is there, children. See here. A wire of 20 ohm is there. It is bent in the form of a square. It is bent in the form of a square. In square, all sides are equal.
Equal.
In square, all sides are equal. So 20 by 4 is how much? 5. So
5
here
ohm.
5, here 5, here 5, and here 5. Across any two ends of its diagonal, diagonal they are asking the resistance. These both are connected in 5 are connected in
Series.
yes, children. 5 and 5 are connected to same wire. So series. These both are connected in
Series.
series.
Parallel.
10 and 10 are connected in
Parallel.
parallel. So 1 by 10 plus 1 by 10.
2 by 10. Reverse.
5 ohms. Okay, children. So answer is 5 ohms, children. Next question, children. Seventh question. How does resistance of moving conductor depend on voltage? Children, how does the resistance depends upon the voltage? Normally, V is equal to IR. Okay, children, resistance do not depend upon voltage, remember, because resistance is constant. R is equal to V by I. Okay, resistance depends only on length, and resistance depends upon area. Resistance depends upon material. Resistance depends upon temperature. So, resistance do not depend upon potential. Resistance do not depend upon potential. Resistance do not. It is because it is a constant. In Ohm's law, it is a constant. In Ohm's law, we have taken this as a constant, children. Resistance do not depend upon resistance, the voltage. Okay, children? Next question. State the difference between wire used in element of heater and fuse. Children, what are the characters of fuse wire and heater wire? Do you remember, children?
Low resistance and low melting point.
Low
Low
resistance,
melting point, low resistance.
low resistance,
High
low melting
melting
point.
point, high
High resistance
resistance.
and high melting point.
High resistance and high melting point. I hope everyone of you remember that, children. Fuse has low resistance because current prefers to go from
Current
low
prefers.
resistance. And low melting point because if excess current comes, it will become hot, melt, break, stop. If excess current comes, it will become hotter, melt, break, stop. It will break and current will stop. And why high resistance? Because if current gets obstructed, it becomes hotter. And why high melting point? To withstand, when it becomes hot, it should not melt. Why high melting point? When it becomes hot, it should not melt because so much hot it will become chilled. That's why. Nice question. Electric fan or motor becomes warm when continuously used for a long time. Why any electrical instruments when used for a long time becomes warms? Because all the work done in moving a charge is converted. Children, all the work done in moving charge. All the work in done in moving charge is converted into heat. Is converted into heat. All the work done is converted into heat, and also we can say Joule's law of heating. We can also say Joule's law of heating. We can also say Joule's law of heating. Okay, 10th question. A 9 ohm resistance is cut into 3 parts and connected in parallel. Children, 9 ohm is there. Children, they are
3 ohms,
connected.
3 ohms.
Three children, because 3 equal parts means 3 ohms, 3 ohms, 3 ohms, children, because the resistance is directly proportional to length. These 3 ohms are
Connected
connected
in
in parallel. This 3 ohms, this is 3, this is 3, this is 3. When so many equal resistors are connected in parallel, what is the formula?
R by N.
Rp is equal to R by N.
N.
3, and how many are there? 3. So
3.
1 ohm. 1 ohm. 3 resistances each one. And how many are there? 3 are there. 3 by 3 is 1 ohm. Okay, children? Are you able to understand, children? Please practice, children. How much you practice, that much strong you will become in the subject, children. 11th question. Electrical appliances draws a current of 0.5 amperes. Current is drawing 0.5 amperes. Okay. And applied voltage is 220 volts. V is equal to 220 volts. Vaishnavi, tell me this answer, Nana, how to do? You have to find out charge. Time is 30 minutes. Vaishnavi, will you help me?
Yes, sir. Yes, sir.
Tell Nana.
Oh, yeah. Yes, sir.
We have formulas for heat. How many formulas are there, Nana? Formula for heat. We have
Three from
VAT,
three formulas are there, sir.
I square RT.
I square RT.
Among these three, which one will use?
We'll use the first one, sir.
First one. Chalo. V how much?
0.5.
220. V is 220. No?
Oh, yeah, 220.
I is
0.5.
time is
30 minutes into 30.
Into 60. 30 minutes to 60. Okay. Okay, if you remove this, children, this 0, 2s are 110. So 110 into 30 into 60. So 11 into, okay, 33 into 6, 36 is 1860. 198,000 joules. This is the answer, children.
So why you did into 60 again?
Huh? Minutes to seconds. They gave in minutes.
Yes.
Yeah. If you want joules, it should be in seconds. 12th question, children. The resistivity of the copper wire is, children, the resistivity of the copper wire is 1.7 into 10 to the power of minus 8 ohm meter. What length of copper wire of diameter? 0.1 mm. 0.1 mm. What length? It should be taken so that its resistance becomes 34 ohms. Okay, 1.7 into 10 to the power of minus. Children, diameter is, see here, 0.1 mm. So radius will be how much, children? 0.1 by 2. So radius is 1 by 20, because if I remove this point, 0 will come, children. Okay, how to convert mm into centimeter, mm into meters? By 1000. Mm to meters by 1000. Okay, Grishma, can you tell this? How to do?
Yes, sir.
1 by 2
R
into?
10 to the power of 4.
Okay. 1 by 2 is? We'll keep it
0.
like that.
0.5.
We'll keep it like
0.
that. Okay, okay, we'll
Okay,
keep it
sir.
like that. Okay, now tell me. R is equal to?
PL by A, R equals to 1 by 2,
34,
24 equals to
34
1 by
into, this is 17 into
70 into 10 to the power of minus 9 into L by 22 by 7 into 1 by 2 into 10 to the power of 4 into 1 whole square.
this entire thing goes there. So 34 into 22 by 7 into 1
1
by
by 2 into 10 to the power of 4 whole square.
4 into 10 to the power of 8 is equal to 7
17 into 10 to the power of 9 into L.
This also goes down. If it goes down, what happens? L is equal to
L equals to 34 into 22 in 17 into 10 to the power of 9 into 4 into 10 to the power of 8.
17 twos are. Okay.
2 ones are 2 twos are 4.
22 by 7, what we can write down?
3.14.
So 2 into this
3.1.
twos are, it will go. 3.14 by 2 is how much? 3.14 by 2?
1.5 into
57. So minus 8 plus minus 9 plus 8 is how much?
minus 1
Minus 1 if it comes up.
plus 1.
So 1.57
57 into 10. 5.
15.7 meters is the resolution. So you should be careful, children. If you practice, then you will get it, children. Okay, like these questions are very, very important, children, because they are asking in board exam. 13th question, children. Draw a schematic diagram of an electric circuit consisting of a battery of 5 2 volts. Children, 5 2 volts batteries. 1, 3, 4, 5. Okay, children, there are 5 2 volts batteries are there, children. So plus, minus. Okay. These are each one 2 volt, 2 volt, 2 volt, 2 volt, 2 volt. Okay, schematic diagram they are asking,
10
children.
volts total.
Yeah. Consisting of a 20, 30, all in series. 20 ohm, 30 ohm, and anything else is there given. 20 ohm, 30 ohm, and plug the key. Plug the key also they want, children. Plug the key. Plug the key means it looks like this. If you put dot, current is going. If you don't put dot, current is not going. Your wish. Okay. Calculate the value of current flowing through 20 and power in 30. He's asking I20, P30. Children, whether they ask you to draw diagram or not, without diagram, if you do the sum, I will not give the marks in the exam. Now only I'm telling you. Here they ask the diagram, but without drawing circuit diagram, if you go in question, I will not give marks. Because without doing circuit diagram, how you will understand? Yeah, total voltage is how much, children? 10 volt.
10 volts.
Total resistance is how much, children?
50 ohms.
I is equal to?
V by R. I is equal to 10 by 50. I is equal to 1 by 5.
I is equal to 1 by 5, that is 0.2 amperes. If this is 0.2 amperes, even I20 will be?
0.2 amperes as current is constant in series.
Current is constant in series, children, so I20 also will be 0.2 amperes only. Now power across 30.
VI.
Which formula will you use, children? I square R will use? I square R. Because current is there, resistance is there. So P30 is equal to I is how much, children? I is how much? 0.2 square into 30. P30 is equal to 0.04 into 30. Okay, P30 is equal to 4 by 100 into 30. 0, 0 cancel. P30 is equal to 12 by 10 means 1.2 watt.
So what did they ask? Potential or power?
Power, no, power, no. They asked power.
Yes.
My God. They asked power, children. Okay, so power across 30 ohms they asked. I show you, children. Okay, 14th question. Children, please everyone copy, children. Yesterday, KET, I told you to submit the notes. You didn't submit. 15th question. 14th question. Okay, I told 13th question. This is 13th. Yeah. Now 14th question, children. Sorry. 14th question is like this, children. What do you see? Can anyone tell what this symbol represent? Anyone? What does this symbol represent?
The
Anyone?
wire is not passing, sir. It will go above it.
Yeah, wires crossing each other without touching. Wires crossing each other without touching. wires crossing each other without touching. Okay, can anyone tell me what is this symbol represents, children? This symbol represents what?
Photoresistor.
Variable resistance or rheostat. Variable resistance or rheostat. Variable resistance is used to alter the resistance in the circuit. Okay, next 15 question. Please listen, all of you. Concentrate. Oh, 14th only one more bit is there, children. The potential difference in the terminals of heater is 60 volts. Potential difference is 60. When it draws a current of 4 amperes, Prerna is there. Prerna, tell this some. Find the resistance. Prerna is sleeping. Okay. So what is the formula we will use, children? Ohm's law. V is equal to.
Equal to IR.
V by I.
Equal to V by
So R is equal to 60 by
4.
15 ohms.
15 ohms. Very good. Very good. Okay. So next 15th question, children. A wire of 3 ohm resistance and 15 centimeters length is stretched to 45. Children, a wire of 3 ohm, initially 15 centimeters. Now it is stretched to 45 centimeters. Okay, it is stretched to 45 centimeters. Calculate new area. Original area we don't know. Calculate new area. Calculate new resistance. And calculate new resistivity. Assume the wire has uniform cross-sectional area. Children, uniform cross-sectional area. So children is very, very important. Some children like this questions. If you can't get, you should not get confusion. First, let me finish up one small job, children. So resistivity does not change, children. Resistivity do not change. Why resistivity do not change?
Because it does not depend upon length and area of conductor.
Yes, resistivity does not depend. Okay, children. Now, new area, children. See if length is becoming 3 times. 15 3 is a 45. Length is becoming 3 times means area will become 1/3 of original. Area becomes 1/3 of the original. If length is becoming 3 times, area becomes 1/3. If length is becoming 3 times, area becomes 1/3. Some people may ask, how sir? Can you show us?
Resistance is directly proportional to
No,
length.
no. Volume is first volume and second volume of the wire is same. Volume of a cylinder is actually cylinder, children. A1 L1 is equal to A2 L2, children. A1 by A2 is equal to L2 is 45, L1 is 15. So A1 by A2 is equal to 3. So A2 is becoming how much, children? A1 by 3. In terms of area, and in terms of radius means you have to take pi r square h, children. But in terms of area, he asked, I did in terms of area. Okay. Now, R1 by R2 is equal to rho L1 by A1 is first one. Shall I do like this and show? And R2 is equal to rho L2 by A2. Okay, children? Now, R2 is equal to rho. What is L2, children? What is L2?
L1.
3L.
3L1.
3 times L1.
1 second, children. Yeah, 3 times. So, R2 is equal to rho into 3L1 and A2 is A1
1
by
by 3.
A1 by 3. So R2 is equal to rho L1 by A1 into 3. This 3 also goes up into 3. But this is R1 no, children. So R2 is equal to R1 into 9. R2 is equal to 9 R1. Resistance becomes 9 times original. Resistance becomes 9 times original. Resistance becomes 9 times original. So resistance 9 times. Area is becoming how much? 1/3 of the original.
1 by 3.
Area is becoming 1/3 of the original. And resistivity is not changing. Why resistivity is not changing? Because resistivity does not depend on anything. Resistance is becoming 9 times. Okay. 16th question. So children, 16th question. Wire of resistance 10 ohm is bent in the form of a circle. Children, 10 ohm is bent in the form of a circle. Find the effective resistance across any two ends of its diameter. Children, 10 ohm across the diameter means here half will be there, here half will be there, children. Here half is 5 ohm and 5 ohm. 5 and 5 are in
Parallel.
So 1 by Rp is equal to 1 by 5 plus 1 by 5. 1 by Rp is equal to 2 by 5. Reverse. Rp is equal to 5 by 2, 2.5 ohms. Okay, children, hope you are able to understand. 70th question. Electric lamp is marked 25 watt and 220 volt. It is used for 10 hours daily. 10 hours daily. Okay, children. First question, what is resistance? Second question, what is energy in kilowatt hour? Third question is, that's all, that's all. Two questions. So first question is resistance, children. So we know P is equal to V square by R. You know this formula, no, children? P, three formulas are there. P is equal to V square by R. So P is 25. V is 220 into 220 by R. R goes up, 25 comes down. R is equal to 22 into 22 into 100. This zero I kept here, children, by 25. 25 fours. So R is equal to 22, 22 is 484 into 4. R is equal to 4, 4, 16, 32, 33, 4, 4, 16, 1936 ohms. 1936 ohms, children. Now, kilowatt hours, children. Power in kilowatt hours. Power in kilowatt hours. Children, heat is equal to power into time. Heat is equal to power into time. Power is how much, children? 25 watts. Time is how much, children? 10
10
hours. How to convert watt to kilowatt? Anyone? Watt to kilowatt? How to
into
convert?
Into thousand, into thousand.
Hey, by 1000. Watt to kilowatt is by 1000 into 10. Watt to kilowatt is, kilowatt to watt is into 1000. Okay, so 0, so H is equal to 0.25 kilowatt hour. Okay, children. So children, 25 watt is there, no? I converted into kilowatt by putting 1000. So and into times 10. This is gone 25 by 100 is 0.25 kilowatt hour or 0.25 units in one day. One day, this much units are consumed. Okay, children. Hope you are able to understand, children. Next question. This is 17. Next to 18th question. 18th question. Please concentrate, children. Everyone. 18th question. The electric power consumed by a device may be calculated by using either of the two expressions. P is equal to, we can use I square R. P is equal to V square by R also we can use. Or seriously speaking, P is equal to VI. Telling you just like you. The first expression indicates that current is, first expression indicates that power is directly proportional to resistance. And second expression indicates that power is inversely proportional to resistance. How can the seemingly different dependence of power on resistance in this expression can be explained? Can anyone explain? Here directly proportional, here inversely proportional. How is it possible? Can anyone explain? How can the same power once directly, one inversely? Can anyone explain? Yes. Children, this formula we should use in series connection. This formula we should use in parallel connection. Why, sir? Because current is constant in series. Current is constant. In series, power is directly proportional. Whereas power is inversely proportional because in parallel, potential is constant. In parallel, potential is constant. Then where we should use this mixed connection, we should use. Okay, but sir, you are showing by using all the formulas, same answer you are getting, no sir, then why are you telling this in series, this in parallel, you may ask. So children, what happens, sir? Here current is constant, that's why I'm telling you, the current is constant, that's why I'm telling you to take that formula. If you take that formula also, you'll get, or else individual potential will find out and we'll use this formula, anything is okay. But seriously, this is used in series, this is used in parallel because current is constant, potential is constant. Current is constant in series, potential is constant in parallel. That's why you will get like that, children. So in series, power is directly proportional to resistance. Remember, in series, power is directly proportional to resistance. In series, power is directly proportional to resistance. Basing on this, sometimes they ask questions like this also, children. 60 watt bulb, 40 watt bulb are connected in series. So 60 ohm bulb, 40 ohm bulb are connected in series, which will have more glowing. So because this is having more resistance, it will have more power, so it glows more. Like the questions will come, children. If watt is coming directly, you can say 60 watt, children. Okay. Next question, children. 19th question. A simple circuit consists of resistor, battery, and wires, children. Resistor. How, children? First question. Normally, okay, children. Resistors, battery, and connecting wires. Children, normally, how will you connect voltmeter? Yeah, first question.
In parallel.
Parallel.
Voltmeter we will connect always in parallel. This is plus, this is minus. So this is also plus, this is minus. Voltmeter is always connected in parallel. Voltmeter is always connected in parallel, underline parallel. Why? Because it has
High resistance.
high resistance, underline high resistance, leave one line gap. This is first question. Second question. Second question they are asking, how must ammeter should be
In
connected?
series.
Ammeter is plus means plus, minus means one. Ammeter should be connected in series. Ammeter should be connected in series, underline. Why? Because
Because it has low resistance.
it has low resistance. Because it has low resistance and it should measure current. It should measure current. Okay, low resistance. No problem. Third question is that draw the circuit diagram. This is only circuit diagram. Children, if you want, you can put some decoration also like plug key. Decoration means not something plug key. I mean to say. I want to put rheostat means put, you can put rheostat also. But they didn't ask no. Why should we put means no. Don't. Okay, children, it's up to you. They didn't ask. Just show like that enough. Whatever they ask, you show that only. Because if you put everything, what they will think means you don't know what is what. That's why you are drawing everything. They will think. Okay, 20th question, children. A wire of given material length L and area of cross section A has a resistance of 2 ohms. 2 ohms L A. Find the resistance of another wire of same material but having L by 2 and area is A by 2. What is the resistance of this wire? Okay, children. So children, we know R1 by R2 is equal to what is R1, children?
Rho L by A.
L1 by A1. What is R2, children?
Rho
Rho
L
L2
by
by
A2.
A2.
Rho cancel.
This comes here, this comes here. Okay, children. So R1 by R2 is equal to L1 A2 by L2 A1. I hope you are able to understand, children. So R1 by R2 is equal to L1 is L1, A2 is A1 by 2, L2 is L1 by 2, and A1 is A1 only. A1 is A1 only. I hope you are able to understand, children. Please concentrate. Please concentrate. Okay. So 2 cancel, L1 A1 cancel, R1 by R2 we got it as 1, so R1 is equal to R2, means R1 is 2 ohms, so R2 also 2 ohms. Or else directly we will put here, because R1 is 2 by R2 is equal to 1. This comes here, R2 is equal to 2 ohms, so resistance did not change. When length is made half and area is made half, resistance did not change. When length is made half and resistance is made half, resistance did not change. Okay, children? When length is made half and area made half, resistance did not change. Okay, children? Yeah, next question, 21st question. Children, they have given a circuit. Children, please see here all of you like this, like this, like this, like this, like this. Children, this is 3 ohm, this is 3 ohm, this is 3 ohm, this is 0.5 ohm, this is 0.5 ohm. All of them are connected to 3-volt battery. This is the circuit.
Sir, can I say?
Find the current in the circuit. Yeah, who want to say? Say.
Sir, can I say, sir?
Yeah, tell. These both are in. These both are in.
Series, sir.
These
3
both
and
are in series because they are connected to same wire. Now the circuit changes like this, children. Please see here, children, all of you. Now this is 3 plus 3, 6, children. 6, 3, 0.5, 0.5. These both are how they are connected?
Well, sir, 1 by
Parallel.
6 plus 1 by 3.
1 by 6 plus 1 by 3. 1 by
6
R is equal to 6 LCM 2 plus 1.
plus
1 by R is equal to 3 by 6.
Sir, why 2 you took, sir? 1 plus, okay, sir.
1 plus 2, okay, no problem.
Okay,
1
sir.
by 2. R is equal to 2 ohms, children. Now the circuit becomes like this, children. Please see here, all of you. This is
They're
0.5.
connected in series.
This is 2 ohms because this both are 2 ohms, and this is 0.5. They all are connected to a 3-volt battery. Now what is the total resistance? 2. They all are in
Series, sir.
series 0.5 to 0.53 ohms, and V is equal to 3
V is
volts.
equal to to 3 ohms. V is equal to IR, I is equal to V by R, I is equal to 3 by 3, I is equal to 1 ampere.
1 ampere is flowing in the circuit. You have to show the changes in the circuit directly. I will do. You take it. I will throw on your face. Means we won't accept children. You have to show each and every step. 1 step, 2 step, 3 step. How you are getting every step. You have to show directly. If you write the answer, directly will cut the marks, children. No mercy regarding it. Last question for the day, children. Question is like this. 22nd. Last question. Remaining questions will do tomorrow. Okay. There is a VI graph. There are 3 graphs, children. A, B, C. These are the 3 graphs. First question. The VI graphs are individually shown to color. Out of A, B, C, which one represents graph for series combination? Which is series? Anyone? Which represents series combination? Anyone?
So
Answer is C, children. Answer is C. Why? Because it is nearer to B, so it is series. Why it is series? Whichever is nearer to B, I told high resistance, so it has high resistance. C has high resistance. Normally, series have high resistance. Series have high resistance. Series have high resistance. So C is the answer, children. Because whichever is nearer to B, that will have more resistance. In series, resistance will become more. In parallel, less. Series more. Parallel, less. In series, more. Which is in parallel among these 3? Which is in parallel? A is in parallel. This is in series. Among C and A, which is having more length? C. Children, more resistance here, less resistance here. Resistance is directly proportional length, no? So more length. And resistance is directly less length. Resistance is inversely proportional area, no? Area less, and here area more. Which have high temperature, resistance is directly more temperature, less temperature. You should understand, children. I told you all this thing so many times. Since resistance is more, it is in series, more length, more area, more temperature. Since resistance is less, it is in parallel, less length, less area, less temperature. Like that, you should analyze, children. Thank you so much, children. I hope you don't have any doubts, children. Thank you so much.